Okay, this is the last unit we're going to cover. We're going to be talking about data and statistics. And in this first section in Unit 12, we're going to talk about how we can make scatter plots. So let's write the word plots right here. So scatter plots. And as a warm-up, we're just going to do a little bit of graphing review. So it says graph and label the following. So we want to graph the point A, which is 2, 4. So we're going to go over 2 and up 4. Remember, x coordinate first, then the y coordinate. We're going to go horizontally, then vertically. So there's A. B is negative 5, 1, so we're going to go left 5 and up 1, so B would be right here. And then C is going to be negative 3, negative 6, so back 3 and down 6, so way down here, that's going to be C. Then we want to graph and label these two lines. The first one is x equals 3. Remember, if you only have one variable, it tells you which axis it crosses. So this is going to cross the x-axis at 3. It only crosses the x-axis. There's no condition on what y can be. So it goes straight up and straight down. There's the line x equals 3. The other one is y equals negative 2. We're going to cross the y-axis at negative 2. So we're going to cross right here. And we go as far left and as far right as we want. So this is y equals negative 2. Remember, y equals a number is a horizontal line, flat like the horizon. X equals a number is a vertical line, like a vertical cliff there. There's no slope that represents how steep that is. And then if we take a look at C, we've got this equation right here with both an x and a y. This is a linear equation. We graphed a whole bunch of these earlier in the year. So what we're going to do to graph this, I'm going to zoom in just a tad. And let's put this in slope-intercept form. So gosh, we got to go back and remember what that is. We want to put it in this form right here, y equals mx plus b. So in order to do that, we're going to move the 3x to the other side. So we're going to subtract 3x here and subtract 3x here, kind of keeping it out of the way of the graph there. Those are going to cancel each other, so we're going to have 4y equals, and then we usually write them in alphabetical and descending order. So we're going to write negative 3x with the constant of 8 at the end. Then we're going to divide by 4. Now, if we divide both sides by 4, we're doing the same thing to both sides, but essentially what happens is we end up breaking this up into two parts. So this is going to be negative 3/4 x, and then we've got the 8 divided by 4, so that's going to be a positive 2. So this is what we're going to graph. And again, we start at the end. We start with the y-intercept. So there's the y-intercept right there. And then the slope is negative 3/4. So we've got a b of 2 and a slope of negative 3/4. So we're going to cross at 2. And then the slope is negative 3/4. So this is the rise over the run. So we're going to go down 3 and we're going to run 4. Down another 3 and we're going to run 4. So it's going to look something like that. Then going the other way, instead of going down 3 and right 4, we're going to go up 3 and left 4. So that's going to put us about right there. These points do line up, which makes us feel kind of good. We're going to extend the line to the ends of the graph, and there we go. That is the graph of that linear equation. Now, that's a good review because today we're going to be doing some graphing. There are many times when two numeric variables, so write the word numeric there. We've talked about the word numeric before. It kind of sounds like number, and that's what it means. So two number variables might be related. Some examples would be things like this. How much someone works is closely related to how much they get paid. So usually the more they work, the more they get paid. Shoe sizes are somewhat related to a person's height, and the number of dumb things we do each day is usually related to how old we are, but not always. Depends on who you are, I suppose. A graph that can show a potential relationship between two numeric variables is called a scatter plot. And you'll see why we call this a scatter plot in just a second. So let's talk about how we make a scatter plot. So this is how we're going to make a scatter plot. We collect the bivariate data. We collect the bivariate data. Now the word bivariate is kind of a fancy word. It's a weird word, and all it means is it's a fancy word for two variables. So we collect two variables about the same person or about the same situation or whatever it is. The second thing is we graph the data on a coordinate plane. Coordinate plane, and that's just a fancy word for an xy plane. Now we aren't always going to use x's and y's. We could label the variables and things like that, but for the sake of this, let's just think of it as an xy plane. And then the third thing is we look at the results to determine if there is a relationship or a pattern. Let's write the word pattern right here. And this is going to be really important that we're looking at the data that we graph and say, hey, can I kind of make some guesses about what's going on here? Could I make a statement, kind of a conclusion? Is there a pattern here that I can see in the graph? So we're going to try a couple of these. We're going to gather some kind of anonymous data. And in a classroom, if you were in one of my classes, this is what you would do. You'd write the following things on a slip of paper. You don't need to write your name on it or anything, but these are the pieces of information that we're going to collect. We're going to do two different examples. So here's number one. The first thing is we're going to collect information about your height in inches and your shoe size, and we're going to write it as an ordered pair. So we're going to write the height in inches first and then the shoe size second. So for an example, if we've got somebody who's 5 feet 2 inches tall and they have a shoe size of 7, here's what we'd figure out. 5 times 12, because we've got 5 feet, 5 feet times 12 inches per foot, that's going to give us 60 inches, and then we're going to add the other 2, so that person would be 62 inches tall, and they've got a size 7, so that means the ordered pair that they would write down would be 62, 7. Again, this means 62 inches tall, that's the same as 5 feet 2 inches, and then the size 7 shoe. The other thing that we want to write down is this. So again, we're doing two completely separate examples. The next one is the month you were born and the number of letters in your last name. So for example, let's say you were born in January, that would be month 1, and your last name was Laws, L-A-W-E-S. So there's 5 letters here. You were born in the first month, so that means the ordered pair would be 1, 5. So if you've got any questions about how to figure that out for yourself, please make sure you ask. We're going to go ahead and do example 1 right here, and this is a really good idea. It's a very good idea to look at the data. Please look at the information that we're going to have right here before scaling or labeling or graphing any points. So I'm going to go ahead and fill this in, and I'll be back in just a second. Okay, so I've got all the data written down here. I filled in all of these, and again, this was just from a class that I did this little experiment with a couple of years ago. So if we go through and look at this, we've got somebody right here who's 66 inches tall who wears a size 10. We've got somebody down here who's 66 inches tall who wears a size 9. We've got somebody who's 58 inches tall who wears a size 3. Somebody with a 61 inches tall who wears a size 6.5. So there's some data. Now this is randomly collected data, so if you were in a different class than this one was, you would get totally different information. Now we're going to take a look at this data, and we're going to kind of examine it before we scale the axes and graph any points. And again, as I said earlier, a good scatter plot has the axes labeled and scaled. So we're going to label and scale the axes before we do anything as far as graphing these points. So we want to take a look here. We've got, let's see, 66, let's see, 70 is kind of the biggest number we've got, and maybe 58 is the smallest number that we have. And notice that this comes first, so I'm going to think of this like the X, and we're going to think of this like the Y. So I'm going to label the horizontal axis as height. I'm just going to write height right here. And that means the vertical axis is going to be shoe size. So shoe size right here. So we've got them labeled. Now we want to scale them. So let's again take a look here. The smallest is 58 and the largest is 70. So what that means is in this direction, we don't have to start down at 0. We don't have any data near 0. So here's what we're going to do. I'm going to draw a little jagged line right here. And when you draw that jagged line, that's called a broken axis. When we break that axis, then anybody looking at this would know, okay, even though there's a 0 mentioned here, the next one is not like 1 or 2 or 3 or something like that. So here's what we're going to do. I think we're going to start at 58 because that's the smallest one. And then let's count by 2 and see how far we get. So this is going to be 58, 60, 62, 64, 66, 68, 70, and 72. Now what that does for us is it allows us to graph all of these points fairly spread out, but not include that 0 there and have to count by 5s or 10s or something like that, just so we can fit everything on here. Okay, let's take a look here. The biggest number is 14. Wow, somebody's got a huge foot there. And then the smallest is 3. Now, I think if we counted by ones, let's see, this would be 2, 4, 6, 8, 10, 12. We wouldn't be able to fit the 14 on there. So we're going to do this. We're going to do a little broken axis right here, put a little jagged line in there. And then here's what we'll do. We're going to start with 3, and then we're going to count by ones. I think we've got enough space to do that. So this is going to be 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So we do have room to fit the biggest one in here. And the nice thing about scaling the axes like this is we're going to be able to spread things out. So notice that we've got some half sizes. Half sizes are going to be fairly easy to locate right in between two of the whole numbers here. So I'm going to go ahead and graph a couple of these really quickly, and then I'll finish the rest on my own, and we'll be back in a second. So let's do 66 inches in size shoe size of 10. So 66 and 10 would be a point right there. So we've got the first one taken care of. So I'm just going to put a check mark by that so I know I've got it done. 70 and 14. So let's do 70 and 14. That would be way up here. Keep going here. 66 and 8. 66 and 8. We're going to be right here. I'm going to go ahead and put all of the rest of them on here. I'll be back in just a second. Okay, I'm back. I've got all of those graphed. A couple of things I noticed is we had two that were 66 inches tall and 8. So what I did is I just put two dots right next to each other. Another thing that you could do is you could just make a big fat dot there. Same thing happened with 63 inches tall and 9. I put them two next to each other. We could just do that. Totally fine either way, as long as you've got those data points plotted on there. Now, the next question is, when we look at this, how can we describe this? What do we notice? Is there a relationship? Is there a pattern? So again, we've got the height in inches, and we've got the shoe sizes over here. And what we want to do is say, gosh, is there any relationship here? Do we notice any patterns about this? Well, one thing I notice is if I were to take this and kind of put a big blob around all of these points right here, kind of make it look like that, it kind of looks like this. It kind of looks like the taller you are, the bigger your shoe size. We don't have anybody who's really, relatively tall. 66 inches is 5 feet 6 inches. We don't have anybody who's really tall who has a really tiny shoe size. We do have somebody who's relatively, short. They've got a shoe size of 3, and we've got somebody who's pretty darn tall. This is 5 foot 10 inches tall, and they've got a shoe size of 14. So we don't see any weird combinations here. It looks like, so if we want to describe it this way, the taller you are, the bigger your shoe size. So let's go ahead and write that down. The taller you are, the bigger your shoe size. And again, all we're looking for here is just a general pattern. Can we say anything about this relationship? So I think we've got that one taken care of. Let's flip over to the other side. And this one is the second example. This is the month of your birthday, and this is the number of letters in your last name. So let's go ahead and do that. I'm going to write down some data here that I collected, and I'll be back in just a second. So I've got the data down here. All of the information is organized right in this little chart right here. So let's take a look. This person would have been born in the 4th month, and they have 5 letters in their last name. So they would have been born in April and 5 letters in their last name. Let's take a look at this one. This one would have been born in the 12th month, so December. They have 7 letters in their last name. 10th month right here, 7 letters in their last name. So we're going to go ahead and chart this data. So again, we want to label this. We're going to think of this as X, and we're going to think of this as Y. So let's label this. This is going to be the month, and over here this is going to be number of letters in their last name, number of letters. So number of month and letters in their last name. So let's go ahead and figure out how we're going to plot this. Now in this direction, we know we've got months from month 1, January, to month 12. So we know we're not going to have to go any more than 12 in this direction right here. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's not enough to do that. So maybe a good thing to do here would, let's just count by 2. So let's do 2, 4, 6, 8, 10, and 12. So again, we're going all the way from January, which would be spot number 1, to December, which would be spot number 12. And then in this direction, this is just the number of letters. Let's take a look here. The biggest we have is 12. Nobody has less than that. So let's just check and see if we can count by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Fits perfectly there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, no need for a broken axis on either of these or anything like that. So I'm going to go ahead and plot a couple of these, and then we'll come back as soon as we're done. So the first one is 4-5, so 4th month, 5 letters in their last name. 8th month, 7 letters in their last name. And I'm just going to keep going like this, so go ahead and finish it on your own. We'll be back in just a second. Okay, I've got the data all plotted. There were a couple things that I noticed. Again, when we're doing a number that's odd, we're going to be off one of these grid lines. So the last one was 1-6. So this is month number 1 and 6 letters in the last name. So we kind of put it in between there. The same thing happened with this 11 and 6. So just like before, the question here is, how do we describe this? Do we notice anything? Is there a relationship? Is there a pattern? Could we make a prediction about like what month you were born and how many letters you have in your last name, or say make any general statements like this? Well, one thing that we can do is, if I were to kind of circle this up with that data right there. Now we do have kind of a weird result right here. We do have this one that was born in July, and they had 12 letters in their last name. So even if we included that one right there, could we really say much about this? Is there a relationship? Well, there's not much of a pattern here, and I'm going to go ahead and write that. There really isn't a pattern on this one. Not much of a pattern. We wouldn't be able to predict anything from this or make any general statements. Because take a look at this. If you're born in April, we've got people that had 5 letters in their last name, 6 letters in their last name, 7 letters in their last name. Kind of a spread. But we also had this. Take a look at these 7s. There were people that were born in April. There were people that were born in August, in October, and December. They all had 7 letters in their last name. There's really no relationship here. And that should kind of make sense. So I'm going to shrink this down, and let's talk about these two examples together. If we're talking about somebody's birth month and the number of letters in their last name, there really isn't any relationship. There's no reason to think there's any type of relationship between the two of those. And we can kind of see that when we do a scatter plot like this. Now, if we're talking about how tall somebody is and their shoe size, generally speaking, people that are taller do have bigger feet. They have to wear a larger size shoe. So this is the type of thing that we're interested in investigating and figuring out from a scatter plot. If we just have the data here, it's really a jumble. It's hard to tell what's going on. But the minute we plot it on a coordinate axis, label those, scale things appropriately and things like that, we can kind of see that this is just kind of a big blob right here. There's not much of a pattern. While this, we can clearly see that the taller somebody is, the bigger their shoe size is generally. And that's the pattern that we wrote down. So today we're just going to be practicing coming up with scatter plots from data, and then maybe making it kind of a general statement about whether or not there's a pattern. Good luck on the assignment.